Hey everyone, today we're going to discuss about the behavior of an exponential function. Now, whenever we talk about the behavior of an exponential function, we check what will happen to the graph whenever we change values on its function. Now, behavior can come in two ways. There is a translation and there is a reflection. Now, translation refers to the horizontal or vertical shift of the graph without changing its shape, while reflection refers to the transformation that produces a new figure, which is a mirror image of the original figure. Now, in analyzing the graph of an exponential function, we will make use of a particular layout of an exponential function. This is f of x is equal to b raised to x plus h. Then the entire function will be added to k. Now we will manipulate the parameters h and k, and we will analyze what will happen to the graph. Okay, let's graph some functions. So let's have here f of x is equal to 2x. Let's graph it right here. So f of x is equal to 2 raised to x. So this is the graph of the function. Now let's see what will happen if we add 1 here on x. So let's have another function, but this time we'll have 2 raised to x plus 1. So let's write here, let's say f of x is equal to 2 raised to x plus 1. So remember that this one is our original f of x, and this is the new one, the 2 raised to x plus 1. As we can see here, they're both asymptotic to the x-axis. And look at this point here, it's 0, 1, but the counterpart of the other graph is right here. It shifted 1 unit going to the left. So 1 here, 1 here. And the same thing happens consistently on other points of the graph. So this means that if we add 1 onto the exponent x, the graph shifts to the left. So as we add more x's here, as the h increases, the graph shifts to the left. Now let's see what will happen if we subtract a value to x. So this becomes f of x equals 2 raised to x minus 1. We change the function as x minus 1 instead. 2 raised to x minus 1. So this is the graph of 2 raised to x minus 1. And take note that this is our original, right? So from here, the graph now moves 1 unit to the right, like that. So the shifting of the graph going to the left or to the right depends on what is added onto x, or rather the change in h. As h increases, the graph shifts 8 units to the left, while if h decreases, the graph shifts 8 units to the right. So that's the translation of the exponential function to the left or to the right. Now, let's see what will happen if we change the value of k in our function. So this is the graph of f of x equals 2 raised to x. Now this time I will add 1 to the entire 2 raised to x, not just only on x. So let's name it as g this time. So g of x is equal to 2 raised to x. Then the entire function will be added to 1. So let's see what will happen to the graph if this happens. So g of x is equal to 2 raised to x, then plus 1. As we can see here, the new graph is not asymptotic to the x-axis, but instead it is asymptotic to the horizontal line y equals 1. And if we observe the points here, all of the points moved 1 unit upward, just like that. So 1 unit upward. All the points moved that way. So if we have k as greater than 1, as greater than 0 rather, and it increases and it decreases, then the graph moves upward. So we can see here that if k increases, the graph shifts k unit upwards. However, if we try to use another graph, let's say our g of x instead is 2 raised to x, but this time let's subtract 1. Let's see what will happen. So what we're going to get is g of x is equal to 2 raised to x minus 1. So let's see. This is the original graph, and we can see here that the new graph is asymptotic to y equals -1. All of the points have shifted 1 unit downward. So that's how it is. They all went down 1 unit downward. So if k increases, the graph shifts k unit upwards, while if k decreases, the graph shifts k units downwards. Now, let's check what will happen if we change the sign of x. So we can see here that f of x is equal to 2 raised to x. There's the graph again. Now, let's see what will happen if we have g of x is equal to 2 raised to negative x. Let's see what will happen if the exponent becomes negative. So let's graph it. 2 raised to negative x. As you can see here, the new graph faces the opposite direction. This original graph increases positively, while this one, it decreases. It's like it's mirrored to the original graph along the y-axis. So that's the effect whenever the exponent becomes negative. It gets reflected across the y-axis. So the graph of f of x is equal to 2 raised to negative x is a reflection of 2 raised to x along the y-axis. We just rotate the graph along the y-axis. So that's the behavior of an exponential function. It's either we have the translation or the reflection. So I hope you learned a lot of things today, and thank you guys for watching. See you guys on the next video.